Hi, my name is Philip. Today I would like to talk to you about another topic, which is how to find rare patterns in your data. So this talk, like other of my videos, are about data mining, analyzing data, and how to find the patterns in your data that are interesting but maybe don't appear so often in your data. So let's start. I think you know already, if you watch my other videos, you know already about pattern mining. Pattern mining is a subfield in data mining or data science where we want to find interesting patterns in the data. Patterns means, for example, it could be some sets of values that appear in your data that have some strong association together. Okay. So if we take the traditional example about shopping, we could analyze the shopping data and find there's a strong correlation between people buy the Coke and buy the chips and so on. Okay, so if we find the associations like this, then we could do the marketing or the cross promotion about these products. So there are many ways to find patterns in data. One of the most popular is called the frequent item set mining. I did some other video about this. I assume that you watched this already, but today I will do a brief review. Okay. So in frequent item set mining, what we want to do is to find the sets of values, what we call items, that appear frequently in the data, the frequent item sets. So there have been a lot of application about this, but today I will talk about the opposite problem, to find the rare item sets. So why we want to do this? Okay, so let's say you look at the shopping data. Maybe you want to find the frequent item set, what do people buy many times together. But there's a lot of things that are frequent that are not so interesting actually. So today we will look at how to find some item sets that are not frequent, but that are still interesting for the user, okay, or for us. So let's have a look at this in more details. So first, before we start, I would like to give you a brief review about what is frequent item set mining, so that it is fresh in your mind. Okay, so frequent item set mining is a popular problem in data mining. The input is a database we can call a transaction database, like for shopping, but it could be other things also. But here we use the example about shopping because it is easy to understand, it is meaningful also, okay, to give some examples. So here we have a transaction database. It is a set of records or lines that we call transactions. Here we have 4 transactions, T1 to T4, and each transaction is a set of items, like pasta, lemon, bread, orange. That means some customer has bought these items together. Another transaction, transaction 2, is pasta and lemon together. Transaction 3 is pasta, orange, and cake together. Transaction 4 is pasta, lemon, orange, cake together, and so on. So now, if we have the data that has this kind of format, okay, some record of transactions, and with some items, like the products, each transaction is a set of items, then we can set a parameter we call the minimum support. It means the minimum frequency. If we set to 2, for example, it means we want to find the frequent item sets, all the sets of items that appear in at least 2 transactions of our database. So here, for example, for this task, the result is what you can see at the bottom of the slide. So for example, lemon is frequent item set because lemon appear at least 2 times. We have lemon, lemon, and lemon. Pasta is also frequent item set because it appears 4 times. And it is 2 or more, so it is frequent item set, and so on. Let's take another one like orange and cake. Orange and cake and orange and cake. So 2 times, at least 2. So orange and cake is a frequent item set. So I explained this before in other video. I will not explain the details too much about this again, but this is just a review, okay? So there have been a lot of research about frequent item set mining, and one useful way to think about this problem is to draw a picture as I show you here. So let me explain this again, okay? So here I take the same example about shopping that I have shown to you before. The letter here, L, is for lemon, P for pasta, B for bread, O for orange, and C for cake. So here in this picture, I draw a Haas diagram, okay? It is a picture that shows all the combinations, all the sets of items that some people could buy in the store, okay? So first on top, you have the empty set, means you buy nothing. Then you have lemon, pasta, bread, orange, and cake. Then 2 items like lemon pasta, lemon bread, lemon orange, lemon cake, and so on, okay? And finally, at the bottom, you buy all the items together. So on this picture, if we set the minimum support to 2, I have colored in yellow color all the frequent item sets. You can see them in the picture. And what is interesting also, we can draw a line between the frequent and infrequent item sets to separate them actually, okay? So in white color, you have the infrequent item sets, and yellow color, you have the frequent item sets, as you can see in this picture. So there's a property that is interesting in this problem. If you have an item set like LO, lemon, orange, is frequent, all the subsets like lemon or orange must also be frequent. So this is a property, okay? And if you have a set like lemon, orange, and cake is infrequent, we know all the supersets, okay, will be infrequent, like lemon, pasta, orange, and cake. So these are some interesting properties about this problem. There are also others, okay? Here I just give you some brief overview. So in frequent item set mining, there's a very powerful property that we use to find the solution. The properties say, if we have an item set Y and there exists an item set X that is a subset of Y, and X is infrequent, then Y must be infrequent also. So what does it mean? Okay, in a simple way. We know that bread is infrequent in our example because bread appears only 1 time, okay? But in my example, I set the minimum support to 2. I want to find the sets of items appear at least twice. So what does it mean? If you have a set like X, like bread, that is infrequent, all the superset of X, like Y, will be also infrequent. So like bread, lemon, must be infrequent because bread is infrequent, okay? So this is an interesting property in frequent item set mining. You know bread is infrequent here in red color, then all the supersets that contain the bread also, all of them you can see on this picture in red color, they also must be infrequent. So we could do the proof about this, or you can also check the example. You will see it is always true. So this is a powerful property used in frequent item set mining to find the solution quickly without looking at all the combination. Because if we know bread is infrequent, we don't need to look at everything with bread. So that was a brief overview, okay? If you watch my other videos, you know about this already. Now I want to talk to you about the rare patterns, okay? So first, I want to tell you some limitations about the frequent item set mining. So in this problem, there is an underlying hypothesis that something frequent must be important in the data. But in practice, it's not always true. Maybe something appears many times in your data, but is not useful. For example, in a store, some products like the bread or the milk, there's so many people will buy these products like bread, milk, and so on, okay? So if maybe you will find a lot of patterns in shopping data with bread, milk, and other products together. So maybe these patterns are too frequent, and there will be a lot of frequent patterns. So you would like to find some patterns maybe that are more rare, okay, not so frequent. But if there are too many frequent patterns with bread and milk, maybe you cannot see the other patterns that are a little bit less frequent but are still interesting. So today I will talk to you about how to find the rarer patterns, the patterns that are not so frequent, okay. So we call this the rare pattern mining. So if we want to find rare patterns in the data, we first need to define what is a rare pattern, okay, because we need to know to define this. So there are different definitions. Here I will give you today some overview about a few definitions. Then you will see how it works. So first, we could say that a rare item set is an infrequent item set. That means if an item set is not frequent, then we say it is rare, okay. So an infrequent item set is an item set X such that the support is less than the minimum support. So here on the picture, the same example, I have put in orange color all the infrequent item sets. So in white color here we have the frequent item sets on top. So instead of finding the frequent item sets in white, now we find all the infrequent item set in orange, okay. So will it be a good idea to do this in general? Not really, okay. Why? So let me show you some observation. First, there are too many infrequent item sets, and even some infrequent item set, they do not even exist in your database. So for example, all the item set on this picture where I have drawn an X, all these item sets have a support of 0, means they don't even exist in your data. So these item sets is not useful to find them, and there can be millions of such item sets. Maybe not in this example because we have only 5 items, but if you have the bigger database with more distinct items, you will have a lot of item sets with the support of 0. So this is not so interesting. Let's look at some other definition. Another definition is used in an algorithm called AprioriRare. Okay, it was proposed in 2007, but it's still very interesting. So here, they want to find the minimal rare item set. We say an item set X is a minimal rare item set if the support of X is less than the minimum support. And also, all the proper subsets of X are frequent item sets. So what does it mean? Okay, the proper subsets. It means if you have a subset Y of X, it must be frequent. So we want to find the item set X that are not frequent, but all the subsets must be frequent. So I don't know if this is clear, but let me show you this again with an example to make this clear. Okay. So we'll take the same example. Here, the minimal rare item set for minimum support of 2. There are only 2 here, bread and lemon and cake. Bread, why? It is a minimal rare item set. Because it is infrequent. It appears only one time. It is less than 2, the minimum. Okay. And also, all the subset of bread are frequent. So the subset of bread, what are they? They are the empty set. Okay, there's only one subset of bread, and it is frequent. The empty set, by definition, appear in all the transactions. Okay. So bread is a minimal rare item set. Lemon and cake. Now let's have a look. Lemon and cake is infrequent because it appears only one time. Okay. So this is okay. Now we need to check the second condition. The subsets are frequent or not. So the subsets are lemon, it is frequent, and cake, it is also frequent. So lemon cake is a minimal rare item set. So basically, what you can observe, all the minimal rare item sets will be close to the line here. You see the line that I draw, the line between the frequent and infrequent item set. So the minimal rare item set, they must always be close to this line that I draw, because the subsets must be frequent. Now let's take another example, like BO, okay, bread orange. This one is not a minimal rare item set. Why? Because it is infrequent. This is okay. The subsets are not all frequent. Okay, however. So bread orange, one of the subset is orange. It is frequent. This is okay. But another subset is bread. It is infrequent. So bread orange cannot be the minimal rare item sets. And all the others here, also, they are not the minimal rare item sets. So here I show you the support also in this picture. Bread and lemon cake have a support of 1. Okay. So this is interesting. In my example, we find only 2 minimal rare item sets. So we don't find a lot. Okay. We find only a few. And what is the meaning of this? The meaning is that these item sets are almost frequent. Okay. So we find some item sets that could be frequent. Almost, they are not, but they are very close to being frequent. So if we want to find the minimal rare item set, how can we do this if we want to design some algorithms? It is not easy. Let me explain to you why. Generally, there are many algorithms for frequent item set mining. They will start from the single item and then they will combine them together to find the larger item set. So they start from one item and combine them to get 2 items, 3 items, and 4, and so on. But in general, as item set becomes larger, the support will decrease. So, because of this, if you want to find the rare item sets, in some way you must pass through the frequent item set to reach the rare item sets. So let me show you this on the picture at the bottom. So the frequent item set are always on top, on this picture. That means on top it is the smaller item set, the small item sets. So the frequent item set are always on top, and the infrequent item sets are always at the bottom. But the algorithms, they always start to search from the small item sets. So if you want to reach the minimal rare item sets, you need to search from the frequent item sets and go down. Go down means to build a larger item set until you find the minimal rare item sets. So how to do this? It's not so easy. So let me explain to you the idea of the AprioriRare algorithm. It is based on a priori, okay? So if you watch my video about a priori, you know the main idea already. But there will be some differences, okay? I will explain after. So as a priori, the item sets will be generated by levels or size. First, we find the item sets with 1 item, then 2 items, then 3 items, and so on. There will be 2 major differences with a priori. If AprioriRare find an item set of size k that is infrequent, AprioriRare will check if the subsets are frequent. If yes, it is a minimal rare item set. And also, AprioriRare will not use the infrequent item sets to generate the larger item sets. This is like in a priori actually. It's not really a difference, okay? So let's see how does it work with an example to make this clear. So we will use AprioriRare on the example database I have shown to you before. So here I will suppose that the minimum support is 2, and the output will be the minimum rare item sets, okay? So the step 1 of this algorithm will be to read the database to calculate the support of all the item sets of size 1. So if we read the database 1 time, we find pasta has support of 4, lemon 3, bread 1, orange 3, cake 2, and so on. Now what we will do next? We will check all the infrequent item sets. If all the subsets are frequent, they are the minimal rare item sets. So here we have only bread that is infrequent. The support is less than 2. We must check the subsets of bread are frequent or not. Now the subset is only the empty set. It is frequent. So bread is a minimal rare item set. Now we will continue, okay? So we keep the frequent item sets after. We have 4. Now we will try to find 2 items together, okay, 2. So what we will do, like a priori, we will combine the items together to do the pairs, okay, 2 items together. So pasta with lemon, pasta with orange, pasta with cake, lemon orange, lemon cake, and orange cake. We do all the combinations. So these item sets, they are candidates. We don't know they are frequent or not yet. Now, the algorithm will read the database to calculate the support of these item sets. So we read the database and we find pasta lemon as support of 3. This one 3, 2, 2, 1 and 2 and so on. Now what we should do next? We look at this to find the infrequent item set. So lemon and cake is infrequent because the support is 1, is less than 2. So we need to check now for each infrequent item set if all the subsets are frequent. So the subset of lemon and cake are lemon and cake. So lemon was frequent, if you remember, and cake was also frequent. So lemon and cake will be the minimal rare item set. Now we continue. We will keep the frequent item sets of size 2 to search for the item sets with 3 items. So here we take the frequent item sets of size 2, we combine them 2 by 2 to make some candidates of size 3, as in a priori. Okay, it is the same thing. Now after this, we read the database to count how many times, and for the infrequent item set in red, we need to check the subsets are frequent or not to decide is it minimal rare item set or not. So these two, they are not the minimal rare item set, because if we look at this one, for example, lemon and cake is not frequent, so this cannot be the minimal rare item set. And this one here, orange and cake, is a subset, is not lemon and cake is not frequent, okay, the subset. So this one cannot be minimal rare also. So what we will do next? We will keep the frequent item sets. So here there are only 2. Okay, pasta lemon orange and pasta orange cake. So from these frequent item set of size 3 with 3 items, we combine them together to make some item set of size 4, like a priori. So here there are no frequent item set, and this is also is not a minimal rare item set. So we eliminate and then we finish, because we cannot make the candidate of size 5. We cannot make item sets with 5 items. So the result is we found these minimal rare item set. There are only 2, as I showed you before on the picture. So that was about the minimal rare item sets. Now I want to show you another definition. Actually, there are several definitions. I want to show you another. Okay. So there is another paper called the for the AprioriInverse algorithm. Okay. So it says that a perfectly rare item set is defined as follows. Okay, so let's read this together. So here we have 2 thresholds, minimum support and the maximum support. And these are thresholds set by the user. And the maximum support must be greater than the minimum. Okay. And we say a frequent item set, Z, is an item set such that the support is at least greater or equal to the maximum support. And now we say a perfectly rare item set will be an item set that is not frequent. the support will be less than the maximum. But it will be also more than the minimum, because we don't want to find item sets with a support of 0. And all the subsets of X, like Y, they must be also infrequent, less than the maximum. So this is the definition used by this algorithm. So I know maybe it's not so obvious, okay? So let's have a look at the example together. So here I have the same definition and I use the same example. So if I set the maximum support to 1.9, the frequent item sets will be on top, okay, above the line here. On top of the line here will be all the frequent item set on top here. So all the item sets on top, they are frequent because the support is at least 1.9. Now, bread is a perfectly rare item set. Why? Because first, the support is 1. It is less than 1.9. Okay, so this is okay. But also, it is at least 1. And there is another condition. All the subsets of a bread must have the support that are less than the maximum. So here for the empty set, bread has only a subset, the empty set, and the empty set is a special case in this algorithm. In this algorithm, we don't count the empty set, okay? So we say the non-empty subset, actually, okay? So bread has no non-empty subset, so it can be the perfectly rare item set. Others, let's say pasta and bread, it appears also once, but it's not a perfectly rare item set because some subset like pasta are frequent. So this one cannot be the perfectly rare item set. So a perfectly rare item set is an item set that all the subsets will be also rare. That's why it is perfectly rare. So let's look at more examples. So here we have another example. We set the maximum support to 3.1 instead, and the minimum support to 1.1. In yellow, again, we can see the frequent item set, and in the pink, we can see the perfectly rare item sets. So to understand more about this example, I think we should have a look at the support of these item sets. So let's have a look. So here we can see, for example, if we look at lemon orange, the support is 2, okay? So to be a perfectly rare item set, lemon orange must have a support at least equal to the minimum support, is 1.1. So this is okay. Now if we look at the second condition, we say that any non-empty subset included in lemon orange must have the support less than or equal to the maximum support. So the subsets like lemon has a support smaller or equal to 3.1, so it is okay. And how about orange? It is the same. 3 is less than or equal to 3.1. So lemon orange is a perfectly rare item set. So we could look at others, but it follows the same idea. Okay, so let's continue. So how to find the perfectly rare item sets? There is some algorithm that has been designed for this. It's called AprioriInverse. It is based on a priori. So if you know about a priori, it is very simple to understand this algorithm. The key difference is in AprioriInverse, we will discard first all the items, the one item, okay, that have the support more than the maximum, because these items cannot be in the perfectly rare item set. So at the beginning, the first thing that the algorithm will do is to count the support of each item. If the support of an item is more than the maximum support, we can remove this item or ignore this item for the other steps of the algorithm. Then, after that, AprioriInverse will search for item sets using the other item, just like a priori, and find the item sets that have the support not less than the minimum support. So, the principle of this algorithm is very, very simple. Compared to a priori, is almost the same. Okay, just change maybe a few lines in your code to get the AprioriInverse algorithm. So, in conclusion, in this video, I talked about the problem of rare item set mining. I give you 3 definitions of rare item sets. To give you some overview, we talked about the infrequent item sets, but we said there are too many, so it's not very useful. So because of this, some researchers have come up with other definitions, like the minimal rare item sets, the perfectly rare item sets. And we saw 2 algorithms, the main idea, okay, about how to find these item sets. There are also some other definitions or other solutions to find the rare patterns that are interesting. I could have talked about other work also, okay, but here I just want to give a brief overview. Maybe in other video we can talk more. So there are also, for example, some other work very interesting where they combine the concept of rare item set with that of correlation. So for example, one algorithm, if you have time you can have a look, called Cori. The idea is they want to find the rare item set again, but they add a measure of correlation to this. Because if something is rare, maybe it is just by chance or not very significant. So to find more meaningful, maybe rare item set, we can add some measure of correlation or other things to find the rare item set that are not just rare but have a strong correlation or other things. Okay, so that's all for today. If you want to try this algorithm, you can have a look at the SPMF data mining library and software. You can search in the search engine on the web and you will find the software. It is open source. You can get the code, have a look at the code, try with some examples and so on. And you can also change it if you want to do some research. Okay, so thank you for watching. If you like it, you can try to support, watch more videos and so on. Okay, see you. Bye-bye.